A very good evening to all our distinguished guests and attendees. I am Sanya Verma, and I'd like to take this opportunity to welcome you all to today's session on Introduction to Serverless and Event Driven Architecture. Our speaker for today is Mr. Eric Johnson. He is a principal developer advocate at AWS and holds expertise in event driven architecture. He has keynoted several large technical events like the AWS reInvent and has been a guest lecturer at global universities like Harvard and Notre Dame. We welcome you, sir.
Thank you, Sonia. I appreciate it, and thanks for having me. Uh, we'll get started. All right.
Yeah,
All right, here we go. So, if you're out there and watching, again, my name is Eric Johnson. I'm super thrilled to be here. I love talking about serverless. I love talking about event-driven architecture. So today we're going to do a bit of an intro. I know in talking to the team as we were getting ready to prepare for this, we were getting this. Y'all are kind of new to serverless. I know we got a lot of students in here, but hopefully you're developers and you're working towards, obviously software development, that kind of thing. So today we're going to talk about how serverless works inside of that. So now a little bit about me before we get started. Again, my name is Eric Johnson. I'm a principal developer advocate at AWS. I've been at AWS for a little over 5 years, which is, 300 years in AWS life. I come from Johnstown, Colorado, which Sonia and I were talking. It's pretty cold here today. It's -6 degrees Celsius. So outside it's a little chilly, but I'm inside, so that works. If you want to follow me, you can find me on Twitter at EDJGeek, or if you look me up on LinkedIn, unfortunately I don't have that on here, but you can find me at single digit or just Eric Johnson AWS will take you to me on LinkedIn. As we're going through, and I'll do this at the end as well, you see down there in the bottom right-hand corner is a website called serverlessland.com. Excuse me. Serverlessland.com is a website that my team manages that helps you understand a lot of what we're going to talk about. Serverless is not, when we think about serverless, it's not just a different language. If we code in, some of us do Java, some of us do Node, some of us do, .NET, Ruby, Rust, all those kinds of things. And when you move from one language to another, you have a conceptual idea, and it's a lot of times just different syntax. It's not usually a different mindset. But serverless is, and specifically event-driven architecture is. So I want to talk about and help you define what are these, what are these terms I'm talking about. So here's today's agenda. We're going to talk about what is serverless, what is event-driven architecture, commonly referred to as EDA. You'll see us throw that around a lot. And why learn serverless? Why, as a student in this, you're like, well, why would I even learn serverless? So before we jump into that, I'm going to give you a couple of rules while I'm talking. Rules is kind of a strong word. If you've never seen me talk, I'm going to give you some guidelines that will help you while I'm talking. The first is, if you can see in the camera here, I'm holding up my hand. This is any number I want it to be. Now I'll hold this up and I may say 7, I may say 12. I have 5 kids, and that's just kind of the way I do things. The second these are quotes, not apostrophes, and I know that this is better than this. And finally, these are thumbs. Now I say that to say I make a lot of one-finger jokes. It's okay to laugh. It's okay to have fun with that. I'm very comfortable being this way. And if that makes you uncomfortable, I'm also comfortable with that. So I'll have a good time either way. Hopefully you're laughing. Hopefully you're having some fun. I like to do things lighthearted. And so let's get started. All right. So the first thing we're going to do is, again, what is serverless? Now, when we started talking about serverless, there's a lot of different ideas on what makes serverless. So we'll kind of climb into that in just a minute. But one of the first services to be called serverless was AWS Lambda. Now, this wasn't the first serverless service, but it was the first one we kind of called that. And what is AWS Lambda? It's a secure, on-demand, event-driven compute service that scales as needed and built only for what is used. Whew, okay, that's a lot of words, right? We're talking about a lot of different things there. Let's kind of break that down, right? So number one, it's secure. All right, so this kind of defines serverless in a lot of ways too. The first thing is with security, we handle all security around serverless services, including Lambda functions. The second thing is it's on demand, meaning you only pay for what is used, right? You use it and then it goes away. Nothing sits out there all the time, but we'll climb into that a little more in a little bit. Third thing is it's event driven. All right. Now I love this idea, and AWS didn't invent event-driven architecture, but we made it much easier, right? And not while not all event-driven architecture is serverless, all serverless is event-driven, right? And if you're going, I don't understand what event-driven means, that's okay. I'm going to explain that in a little bit, right? So AWS or Lambda is a compute service, right? It scales as needed. This is another way we describe serverless. Without you having to manage this, it scales as needed. And again, as earlier I said, you build only for what you use, right? So some of the key things you want to take away from here are only pay for what you use. Security is handled by us, right? That's the physical security and the security between services. Now, does that mean that your code is automatically secure? No, you still have to build secure code. But as far as the security of the services and communication between each other and the physical security, we handle that, right? And the other thing is you never have to patch, manage, or upgrade servers, right? And I let me give you, I've been a developer forever, right? I'm an old guy. I've been developing since 1995, before most of you were born. What you're going to find is in a lot of places, as the developer, especially in smaller shops, when you're hired on as startups and things like that, you're also the DevOps person. You're also the operations. Sometimes you're the janitor. Sometimes you're cleaning the bathrooms, right? So you do a lot of different things. But what we find is you spend a lot of time doing everything but the code, right? So we're going to talk about how we change that and how we can move on for that. All right, so like I said, I crammed a lot of words into this. There were a lot of different things: secure, on demand, event driven, things like that. So let's walk through what this means. Now, to define a compute service, to define serverless, it's easier to look at how we do things now. Now, normally I'm in a room and I have a whiteboard and I'll ask this question. So I'm going to ask it anyway, and I know I can't see your hands go up, but how many of you are developers? How many of you built websites, you've built applications or things like that? Now, hopefully a lot of you or some of you, or if not, are wanting to be, right? And the reality of it, when we build a computer or we build a website, there's some components that have to go through it. And we could talk about, DNS and routers and different things like that. But when it comes down to what we're kind of in charge of is this kind of compute service and the application. So we have our users and they want to get to our website. So we have to deal with a firewall. We have some security. And again, this is before serverless, right? This is kind of a legacy system. We have to have a web server, right? So hey, we got to take care of that. Then we have our code. And a lot of times in our code, we're dealing with routing, authentication, authorization, caching, throttling. And then we finally get to that ever important business logic. Right. And this is the code that differentiates you from anybody else, right? You're building an application. Routing isn't new. Authentication isn't new. Caching, throttling, things like that. But these are all things when you are managing the web servers on a legacy system, you have to deal with all this, right? So at AWS, we said, what if we could get, excuse me, all that other stuff out of the way, and you just deal with the business logic, okay? And the business logic is what you were hired to do. It was what you were brought in to build an app that, I don't know, updates photos or adds a mustache to me or gives me hair or thumbs, right? But you end up doing caching and throttling and routing and authentication and authorization. All that other stuff is what we called undifferentiated heavy lifting, meaning it doesn't help us. The business logic is what sells, right? Salesforce or Amazon or all these different companies that build large applications. It's the business logic that they sell. So that's why we created AWS Lambda. AWS Lambda allows you to just deal with business logic, right? With AWS Lambda, we built a compute service that abstracts all that other stuff and allows developers to just concentrate on what matters. And the cool thing is inside of this, you can run Node, Python, Java, .NET, Ruby, Go. And we also have a custom runtime that allows you to uh, run a bunch of different languages, right? You can run Rust, you can run R, you can run Elixir. We've had people run COBOL, probably languages most of you haven't heard of, you know. Like I said, I'm an old guy. So the idea here is we have a service that you say, literally, you give us the business logic you want to run, and we'll handle all the routing, caching, throttling, authentication, authorization, web server firewall, blah, 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 all the other stuff around that. And you're going, okay, Eric, I see you've got that, but how's that other stuff going to be handled? Well, it's kind of cool. AWS is going to handle, like I already said, infrastructure security, server management, load balancing, web server firewall. And then we have other services that you can configure and tune the way you want to handle things like, and again, these are just examples. There's a lot of other things, but caching, routing, authentication, authorization, throttling. For example, if you wanted to handle routing and authorization and throttling outside of your business logic, you could use a service called Amazon API Gateway. And what you would do is you would have Amazon API Gateway wait and watch for requests like REST API. And then when a request comes in, it would invoke a Lambda function, right? And so between API Gateway and Lambda, we're handling everything that needs to be handled, and your business logic is in your Lambda function. All right, so hopefully that makes sense. And I really encourage you. I know Sonia is watching for questions coming in. I will answer any questions I can. I don't claim to know everything, but I have been doing serverless for a long time. I know a lot of the answers, but if I don't, I know the people who do. So ask your questions. At the end, we're going to have a Q&A where I'll spend some time answering questions for you. All right, so we had another, when we were kind of listing our words of defining serverless, security was a big one. So I want to take a moment and spend some time there, right? So in security, AWS is going to maintain your data centers, right? You don't have to maintain that, right? We're going to patch and secure servers and operating systems. You will never have to upgrade your Lambda function other than your own business logic. You will not have to upgrade the services that run underneath. What's really cool is the way we isolate your Lambda function. It runs in an environment that is isolated from anybody else's. Right? We're going to give you AWS Identity and Access Management, which allows the security between calls. It says, hey, who can invoke a Lambda function and what can a Lambda function do? And then we can help you encrypt data in transit and at rest. So if you're using a DynamoDB or one of the other services, the data is encrypted as it's sitting there waiting and as it's getting put in and pulled out. So that's transit and at rest. All right, so that's some of the security things to understand. And again, the reason this is important is because you don't want to have to deal with all this as an operations, as a DevOps person. You just want to code, right? You want to just now. If your goal is to be DevOps and operations, there's plenty that you can still do in serverless. But if you want to be a developer, you want to code, right? You want to get down to what counts. All right, so we've kind of talked about this idea of a Lambda function, and I explained to you that a Lambda function is on demand, right? It only comes up and it runs when you need it. So if you think about the way services run, and we'll kind of climb into this, we're going to get into what we call event-driven architecture. So this is our second section where we kind of hopefully have defined service a little bit, is this idea of services that you don't patch or manage, you don't handle security, you just architect them together and you create the business logic and run that, right? But then it comes down to, how do these services get invoked? How do I invoke a Lambda function? If it only runs when I need it, and it's not sitting out there listening, which is how normal services work. If you think about a system, right, when we build a computer, if I want to build a website that accepts calls and responds with, I don't know, weather data, whatever. So in the old way, I would have my firewall, web server, all the things we talked about. I'd be sitting on a computer, maybe in my mom's closet, maybe in the cloud, I don't know. But it would be sitting there and it would be waiting for calls. And especially in the cloud, if you have a computer that's sitting there waiting for calls, you're paying for that to sit there. you're paying 12 cents an hour, or if it's a big, beefy, monstrous computer, you're paying, $1.30 an hour or something like that, which may not seem like a lot, but it adds up, right? So if you're sitting out there, why would I have a system sitting out there doing nothing? So what we want to do is we want to get this to where we only react, and again, like with Lambda, we only run when we're needed. So what we've done is we said, okay, we're going to use the event-driven model, and your Lambda function will only come up and run when needed. So what does an event look like, right? And here's the really technical explanation. So if you're writing notes, you want to write this down. Okay, this is super technical. Here's the definition of an event or event-driven architecture. Something happens and we react. Okay, I went kind of fast on that, so let me do it again. Something happens and we react. Yeah, that's probably an oversimplification, but that's kind of the idea. So if I have this Lambda function that's not up and running, how do I invoke the code? Well, I do an event. One example could be Amazon API Gateway. If you set up an Amazon API Gateway is going to sit out there and listen for calls, but you're not going to pay for it. We'll pay for it. We got you, right? What you'll pay for is when traffic actually hits it, right? So we take that, we take that REST API, we convert it to an event, and we invoke a Lambda function. But it can be used for a lot of other things. We often think immediately websites, but really where a Lambda function serverless really shines also is in things like data modification. So let's say we have a storage, an Amazon Simple Storage service, which is an S3 bucket. Hopefully you've heard of this, where we drop a lot of object data in there. We drop a bunch of files, videos, music, whatever, and our Lambda function can be invoked every time one is dropped in there. All right, so that's an event. Oop, a file has appeared. Let's invoke a Lambda. Let's do image modification, save it back, and then the Lambda goes away. Okay, and we'll get more into that in a minute. An IoT device, a button, a light switch, or something like that. If any of you have used an Alexa, that's an IoT device, and Alexa will then, my Alexa's freaking out right now. Let's just turn that off. There we go. And Alexa uses a Lambda on the back end because when you request something from Alexa, that's an event, right? And finally, maybe data dropping into DynamoDB. That's an event. So if something gets saved to DynamoDB, we can take it, invoke a Lambda, enrich that data, and save it back. So if someone saves a zip code to DynamoDB, that's an event. A Lambda function grabs all the weather for that zip code, puts it in with DynamoDB, that's an enriched event. So hopefully you're kind of getting this idea of events that drive invocation of Lambda functions and other things. All right, so another thing we talked about is on demand. Okay, so, and I've been referring to that a whole bunch, but let's climb in a little bit more and help you understand what that means. Back to our legacy system, right? On demand and scale. Well, a lot of times people go, Lambda's cute. That's really cool. I remember when we first came out with Lambda services, Lambda functions. That's neat, but will it scale? Does it play in the professional enterprise world? Can I handle thousands of invocations at a time? Yeah, you can. So let's look at how you would do it if I built a website in a legacy system, right? So I have a bunch of web servers that are running this. And if I'm running that in the cloud, in order to handle lots of servers or services, I need to have many servers. I have them scaling up and down as needed. But again, they scale slowly. They come up, we add more, and then they scale back down. And I'm paying for all these systems to sit out there, right? And so if you're running a website and you need it to be up most of the time, if you need it to be durable, right, you need it to live in multiple regions. You need to be able to route data between those. There's a lot that goes on there. And as developers, again, in small development houses, like, look, I don't want to deal with all that. I don't want to learn how to do auto scaling. I don't want to learn security groups. I don't want to learn different availability zones. So that's why, again, with AWS Lambda and serverless services, we said, you know what, we'll handle that for you. So let me show you how that works. let's go back to our idea. Let's build an application, okay, or let's get an example of an application. Let's say I have a Lambda function that removes sensitive data from provided input, right? So I've got input that's coming in and it's got sensitive data in it, right? And I will call this the scrubber, right? So I'm going to create a Lambda function that scrubs this data, right? So as data gets put in, it'll get pulled out. Now, I could try to write all the code for that. I could write the AI code that figures out what is sensitive data, what isn't, but that's a lot of code. Instead, I'm going to use another serverless service to do this. Okay, I'm going to use Amazon Textract, right? So what Amazon Textract will do is it'll take an image and grab text out of it, and then you can evaluate it. You could use another serverless service called Comprehend if you want, that looks at it and goes, okay, is that sensitive or not? There's a lot of Textract itself can pull out sensitive data, right? So there's a lot you could do with these serverless services, and I'm just kind of chaining them together. So when an image gets dropped in a bucket, it invokes a Lambda function. My code then calls Amazon Textract and says, hey, here's the image, do your thing, okay? And then when it's all done, it saves it to another bucket, right? We can say this is our scrubbed data bucket. Now, this is all well and good when we have one image dropping in. We have one Lambda function, okay? But what happens when a whole bunch of files get dropped in at the same time? Well, what the service does is it then immediately starts bringing up new Lambda functions, right? And what that looks like is we actually take your code that you gave us to run, we put it in what we call an execution environment. We look for an available one, we drop it in there, and then we handle the code. Now, when that happens, that's what we call a cold start. And actually, I'll climb into that in a minute. All right. So we've got these buckets. Let's say 1, 2, 3, 4, 5, 6, 7 images. Now, this can also be 1,000 images. I just don't want to fit 1,000 Lambda functions on this screen. Right. So we've got these. We drop these in. It spins up these different Lambda functions, and they handle it. So what happens when the next image is dropped in? Well, when the next image is dropped in, the Lambda service looks for an available Lambda function that's up and running. This is what we call a warm start. It's already got an execution environment. The code's already there. It's ready to go. If that exists, then it'll use that same Lambda function, right? If it doesn't exist, then it'll spin up a new one, right? So, 3 more, however. So it continues to build these up. All right. So again, let me kind of walk through that. Files dropped in a bucket. We look for an available service or an available Lambda function. If it's not there, we create a new one. And this could do this to the matter of 1,000 concurrent connections at the same time. Now, understand that I'm not saying 1,000 concurrent connections in a second or a minute. I'm saying at the exact same time. That's what that concurrency means, right? So I can all of a sudden go, boom, I'm going to handle all these. And then I stay up there for a while, right? So those Lambda functions can handle this code. Now that 1,000 is per count, right? Per region, and that's what we call a soft limit, and we can bring that up as needed, right? Okay, so what happens? So now we've got this idea. We've said, okay, we bring that up. Now we want to add another one, okay? So we have another service all in the same application. This one, we're going to archive the Lambda function. I'm sorry, archive the data. So we've got one that's going to scrub and another that's going to archive. Because interesting thing is we a lot of times want to save raw data, right? So however we want to do that. So pre-scrubbed, post-scrubbed, however you want to do it. So how does that work? Well, as the bucket gets files coming in, it spins them up for the Lambda functions, for the scrubber, and it spins them up for Lambda functions, for archiver Lambda functions. It's very early in the morning here, so some words are getting run over here. So you get this idea that, so now we have this application that's doing 2 different things, but it's doing them at the same time, right? So we have this parallel compute that I'm not having to go do this, then this, then this. Instead, I'm saying do this and this at the same time. Now, I can do them in order if I need to, but it gives me a lot of power, right? So now you can see here, I've got a bunch of lambdas spun up. Some are active, some are not. So what happens after that? Well, as it spins down, let's say it's nighttime, you don't have stuff getting dropped in, the Lambda functions will eventually start going away. The service reaps them, it takes them back, and they're no longer warm and waiting to be run. Now, again, the only time you're going to pay for that, now, as we were showing warm ones up there sitting, warm, just because they're waiting for calls doesn't mean you're paying for them. In fact, here's how it works, right? So when in Lambda billing, we only pay for the invocation time. It's billed to the nearest millisecond, right? So what that means is while something's being created or it's being unfrozen, depend on if it's brand new or if it's a warm one that's coming active. The invocation is what you pay for, and then we put it to sleep again. We freeze it again, right? We freeze it in memory. Okay. So here's how that works. Again, we build to the millisecond. So Lambda billing, this is a US East. It can vary in some regions, but very minor differences. I'm running an ARM architecture, and it's 0.0000133334 per gigabyte second used. And that's we measure the memory used, and then it's 0.20 per million requests. Now, AWS has a free tier on AWS Lambdas that says you get 1 million invocations per month and 400,000 gigabyte seconds of compute per month for free in perpetuity, meaning not for a year, but for as long as you have the Lambda functions, right? This is just part of the free tier. And what that means is lots of companies have been able to do all their development for almost free because they don't hit the 1 million. This is per account, okay? This isn't per company, it's per account, right? And so they're able to develop for free, and some are even running in production for almost free, right? So this is a very inexpensive way of building applications and building proof of concepts. All right, so we see this pricing. This is how we're built. So let's talk about an example. So we have this application that we were just running, and it's 1.5 million requests. Each second takes 1 second each. So this is 1.5 million images getting dropped into that bucket. Because we're running 2 Lambda functions, we're going to go 1.5 million times 2 functions invocations equals 3 million invocations. Gigabyte second after free tier will equal $1.87. And the requests after free tier will equal 40 cents. So the total monthly incurred cost for Lambda functions in this application that we built is $2.27. So it's a fairly inexpensive way. Now, I'm not going to tell you that as you're growing and you're talking millions upon millions upon millions upon millions of invocations getting hit, that can get more expensive. But it's you scale with that, and your obviously you turn over to your customers, their scale is going to get there too. So I'll give you an idea of how our pricing works and why this is such a cool idea and why this works for proof of concepts. All right. So what do we use serverless for? All right. Well, so many common ideas for serverless are data processing, interactive workloads like websites, things like that, chatbots, cron jobs, Alexa, some of the things I've mentioned. But the chatbots is the one that becomes very interesting, especially within the last year. Now, I know I can't see you raise your hand, but if you are not living under a rock in a cave, you've heard about generative AI. And especially hopefully in your world, you're learning some AI and things like that. And this is where serverless really comes in handy. Okay. So generative AI, and I've got Amazon Bedrock here. If you're not familiar with Amazon Bedrock is a service that allows you to talk to multiple models, right? You can talk to Anthropic Claude. You can talk to Meta's Llama. You can talk to Amazon's Titan. You can use embedding models. This gives you the ability to use LLM, so large language models, foundational models, as needed. The fun thing about Bedrock is it's a serverless service. Okay, so it allows you to only pay for what you use. We'll handle the patching and management. We'll handle the models, the incredible amount of compute power it takes to run the models, things like that. We take care of that for you. In fact, it's an interesting point, and I actually did a talk on this a while back. The reality of artificial intelligence, especially where you're at, is for 99% of us, artificial intelligence is going to be just an endpoint that we consume, right? It's an API endpoint. We may do some training. We may do some, what we call, like different, like indexing and different things like that. But we're not building the models themselves. We're consuming the artifacts or the data that they put out, right? So it's really important to understand how to get the right data to the model, and how to get and what do you do with the data coming out of the model. And this is where we have this suite, and I haven't talked about a lot of them because time, we don't have the time to talk about all of them. But this is where we get into the suite of serverless services that allow you to bring data to the bedrock and take data away from it and only pay for what you use. Right. And so a couple things just real quick. If anything, go look at these later. But DynamoDB on the top there, that's a great service for storing context for chatbots. If you think about building, and I just actually built this the other day, it's very fun. If you think about building basically you're building your own version of it, the chats or the GPT chats that are out there, right? Where when you make a request, we save that, or when you ask a question, let's make it that way. When you ask a question, we save the question to DynamoDB. Then we send the question to one of our models inside of Bedrock. So let's say we're using Claude by Anthropic, right? And so Claude answers that question, right? And then I save the answer in the Dynamo database. Then when the next question comes in, I'm going to take that question. I'm going to grab the first question and the first answer and the new question. I'm going to say to Claude, hey, given this context we've already had, answer this new question. And so that's how these chats work with memory, right? So you've heard of LangChain and things like that. That's where this happens. DynamoDB is where it's one of the best places to save that. Of course, you have your compute, AWS Lambda, which we talked about a lot. Down here in the lower left is the Amazon Elastic Container Service, which allows you to run containers serverlessly. We have step functions. I wish I could see, because I would love to ask how many of y'all have checked out step functions. This is not a step functions talk, so I'm not going to go into that. But I tell you right now, step functions is one of the coolest tools on the planet to allow you to build workflows that run systems. I build almost everything now. I only use Lambda functions when I have to. I always start with the step function, and I can talk more about that at another time. Event Bridge allows you is an Event Bridge bus, allows you to move events around. Simple notification service is a pub sub. Hopefully, as you're developing, you've talked about publications and subscriptions, topics and notifications. And then, of course, queuing with Amazon Simple Service. And these are just some of the serverless services that you chain together or wire together to build applications. So instead of you saying, look, I'm going to build pub sub, queuing, data, all that stuff in my code, I'm going to abstract these to the services that do this so I can get to just my code. Again, it's all about that business logic, right? So that's what serverless offers, right? So that's kind of an overview of serverless, right? Serverless and event-driven architecture is very high level. We can, again, 1 hour to say, here's all about serverless can be tough. But hopefully that gives you an idea of what does it mean to be serverless? Well, I don't patch and manage. AWS handles all the scaling and security for me. And I only pay for what I use, right? And then it's all event-driven. Now, the second question we come to is why learn serverless? Again, you're like, okay, Eric, this is all great, but what does it mean for me? And that's a fair question to ask. As a student, it's like, why should I spend time looking at your technology? Are you trying to sell me something? I'm really not. What I'm trying to do is show you what's happening in the world and why serverless is a really important tool to have in your tool belt, right? So let's take a look at this. Now, these are mostly US companies. Hopefully you've heard of some of them. I think you've drinking a Coca-Cola before. I'm sure you've watched some Netflix. There's a little startup company that delivers packages and books called Amazon.com, if you've ever heard of that. Ubisoft, iRobot, Capital One, I can keep going. And this is just the beginning of it. But these are all companies that use serverless, right? When you walk into a McDonald's, if you've been in a McDonald's that has the ordering screen, they're using event-driven architecture on that. When you walk into a Taco Bell, and I don't know if that's in India or not, but Taco Bell is fast food, Mexican food. You pay for what you pay for what you get, or you get what you pay for. But they have a big screen, and you order everything. It's all serverless. They're using for that technology, right? I can name company after company after company that are using serverless. And the interesting thing is, a lot of the companies are doing what we call a serverless first approach. And that means that everything they build, these are just two examples. Liberty Mutual is a worldwide insurance company. Capital One is a global bank. Both of them build everything in serverless. Now, does serverless meet every workload? Most, especially when you use serverless computers. Yeah, it does. So they start with serverless using Lambda functions and step functions and all those things I showed you earlier. Then if that doesn't work, then they'll bring in serverless containers to kind of build maybe some longer running things, or and we could talk about that maybe when we're doing the Q&A. But why would you? A good question to ask would be, when does a Lambda function not make sense? And I can talk on that. But this idea is the companies. If you're a developer and if you're watching this, you are or want to be. You want to get paid to do it, right? And so the companies that are building, a lot of them are using serverless or want to. That's the big key. They want to use serverless, but are not able to because they don't have the skill set inside of their employment or inside of their employees. So rather than going into a company and saying, well, tell me how you do it and I'll do it that, however you do it. This is the way we've always done it. You can come in and say, look, there's a better way to do this. Companies are scrambling to go to event-driven architecture. And serverless provides that. And so if you could come into a company and say, hey, I know how to build a serverless application. I know how to move that to event-driven architecture. What you're also saying is, I know how to build distributed event-driven applications. And that's money right there. That's gold, because that's reliability. That's resilience. That's, you're helping them build a better product. So I encourage you to check that out. Here's the full story. If you want to grab this QR code, a lot of companies that are building on serverless. So check that out. Another interesting fact is in 2020. This is an old statement, so it's gotten even more so. But Andy Jassy said half of all new applications built with AWS in 2020 are using AWS Lambda as their compute engine. AWS Lambda is a Swiss Army knife of hey, I need to run these cron jobs. AWS Lambda. Hey, I need to modify this data as it's saved. AWS Lambda. Hey, I need to do quick image manipulation. AWS Lambda. Our team built a service called Serverless Video just recently that takes and you stream video, and then it post-processes all that video using either an AWS Lambda or a serverless container, depending on the size of the video. So this is this hybrid account that we're able to do, hybrid approach that says, hey, if a video is longer than 5 minutes, use a container. If it's shorter than 5 minutes, use a Lambda function, because it basically takes advantage best of the both worlds. So, all right, so back to that question. Why learn serverless? Companies need help modernizing their applications. They really do. And you're the ones that do it. It's a newer technology. It's not brand new. It's been around for a while, since 2014, but it's still new to folks. Many folks have not even heard of it. Serverless is a highly sought after skill set in the market today. Put simply, there are good jobs in serverless. And it's a good one to know. So there's more information. I said this at the beginning, but I'll say it now as well. Serverlessland.com. I really encourage you to check out this website. We have, especially as you're getting started, you see at the top there, it's called Patterns, and it's actually under Code now. You do Code, drop down in Patterns, and these are the questions like, hey, Eric, how do I connect API Gateway to Lambda? You talked about it. How does it work? Well, here's an actual template that'll let you deploy that. How do I use step functions with that? Here's a workflow to do that. So we've built a lot of examples on how to use serverless at serverlessland.com. And with that, I'm going to say thank you. Again, you can reach me at EDJGeek on Twitter, and I'm going to turn it over and let's do some Q&A. Sonia, do we have any questions? Oh, I lost Sonia. All right. Well, until she gets back, let me answer the question of, hopefully somebody's asking. Hello, I see a lot of hello, hi, how are you? Um, let me ask this, or let me answer this question. A lot of times people ask, well, when would I use a Lambda? When would I use a container? Things like that. Here are some of the, and these are limitations that we set intentionally. Lambda is specifically designed to be ephemeral, meaning come up, do the work, and go away. So if so we limit Lambda to run 15 minutes. At that, it'll shut down, right? So a Lambda function, one invocation cannot run longer than 15 minutes. So what that means is, like I said, if it runs longer, it'll shut down. So if you've got a process that's running, look, I'm doing this video editing, this serverless video that we built. If you've got a process that runs longer than 15 minutes, then it makes sense to do a container. So that's one reason. The only other one is, like I talked about, how Lambda scales for you, and this idea of a cold start and a warm start. The cold start means we didn't have an execution environment ready, so we had to create one. A warm start meant we have one ready, so we'll just use that. A cold start is very quick, but sometimes it can take like half a second to a second, depending. Usually not. Usually we're talking, like half a second. But there are some things like gaming that you need to have. You need to have super low latency. You need to be 1 millisecond latency. With that, you run a serverless container. So that'll be up, running, and waiting. But because it's serverless, we're running on a service we call Fargate, it's going to scale as you need and come back down. And you can say never go down less than, 10 tasks running or whatever. So that helps there. All right, so I see a question coming in here. I said, what tools and frameworks are commonly used in serverless development? Oh, good question. That's Tanisha. So there we go. Thank you. All right, so we have what tools and frameworks are commonly used. So there's quite a few different ones. One I'm very partial to is a framework called SAM, and this stands for the Serverless Application Model. This is an AWS tool, and what it allows you to do, and hopefully you know what I'm talking about when I say infrastructure as code. So when you're building serverless, you're saying, okay, I'm going to need one Lambda that does this, another Lambda that does this, a third Lambda that does this, and I'm going to need a DynamoDB, I'm going to need an API gateway to wire it all together. Now, I can go into the AWS console and I can create a Lambda, the first Lambda, and then I create the second one, all point and clicking, create the third one. Then I can create API gateway and I can wire up the integration and tell it to connect. And that's great, okay? But in reality, when you're working on teams, you're working in a way that you need to be able to share this. You need to be able to say, okay, Eric, I'm going to build it, but Tanisha, I need you to be able to deploy it as well and run it in your own account and build against it. And then we'll save that in GitHub and we can version and do all the things that developers do. So infrastructure as code is literally a template that describes your infrastructure. It says, I need these 3 Lambdas. I need this API gateway. I need this DynamoDB. And then here's the code for the Lambda functions. And then so SAM does all that. And I can say SAM build, and it can compile everything and get the artifacts ready. And I can say SAM deploy. So that's a very common one. I'll give you and Sonia, if you want to throw this link in the chat, there's a link called s12d.com. In fact, I'll put it in the private chat here so you can see it and pass it. So s12d.com/SWS. Okay. So this link that I'm going to get Sonia to put in if she can is called Sessions with Sam. It's a show that I do that actually talks you through a ton of this, right? All right, so another framework is the CDK. If you're not familiar with the Cloud Development Kit, it does much the same thing, but instead of using YAML as the templating language, it uses code. So it's infrastructure as code for sure. You can use Python, Java, .NET, Node, TypeScript, to declare, and it gives you a little bit more dynamic building of serverless. So, thank you very much. Yes. All right. So next question we have is, how does API Gateway integrate with serverless architectures? All right. Oh, no, I'm sorry. Let's go to this one. How can developers troubleshoot issues in serverless environments? Great question. Okay. So there are some different things we can do. So when you're building serverless environments, you're building distributed applications. So it's not just one code base where you're saying, okay, put breakpoints and things like that. What you're really saying is, okay, you do this little part and you do this little part. So one of the tools that we use is X-Ray. X-Ray is a service we have that tracks system or your events going through the system, basically. So as it hits API Gateway, X-Ray tells you when it hits. As it hits a Lambda function, it tells you when it hits. You can, obviously, in a Lambda function, if you're doing it in the cloud, right, you can read the logs. You can tell your Lambda function to export or print, console.log if you're in Node, or print if you're in Python, print to a log, and then you can read the logs. But let me go back to SAM for a minute. SAM allows you to run a Lambda function locally. Okay, so if we're talking about just debugging code, you can actually run a Lambda function. If you're building that, you can say SAM local invoke, and that link that Sonia shared for us, that has that in there. SAM local invoke, and it'll invoke that Lambda function locally, and you can actually add breakpoints in there, and so you can debug that way. Okay, because and that's again just the code. Those are kind of sanity checks, right? But the reality is, when we're troubleshooting or debugging full systems, you want it in the cloud. So that tracing and reading of logs is super helpful. And then we're constantly working on tools that continue to help. I will throw this out. Another framework. This goes back to this last question and this question. A framework. Another one we have is called Winglang. AWS didn't create this, but a gentleman by the name of Elad has created this. I really encourage you to check it out. Winglang, it has the approach of building like a monolithic app, and then it compiles to a serverless application. So it's a whole new language. You're learning a whole new language to do it, but it's a really interesting approach, and they allow you to debug right there locally in the console. Enough on that, but that one's so that's winglang.io, and that's worth checking out. I'll throw that in here as well. Winglang.io. There we go. All right. Excuse me once. All right. So what's the next question we have here? We had one. How does Amazon API Gateway integrate with serverless architectures? Okay. So I'll handle that one first, and then I'll come down to the other one. So how does Amazon API Gateway integrate? Well, Amazon API Gateway is a full managed API service. It becomes your gateway, right? That's right in the name there. It's the gateway. So when someone makes a standard REST call, right? So you have a method, a resource. If you're not familiar with REST, you want to learn that. I think the last statistic is 83% of all websites still use a REST API, right? So it handles that. And so what happens is it's a service that sits out there, and we handle spreading it across many regions, and it's constantly it's very redundant. So you don't have to worry about that. So your API gateway will, almost always be up. I've never had one go down on me, but we never say never, right? So when that receives the REST response, you then connect it to really multiple integration points, but let's say a Lambda function for the moment. It'll actually send the event to the request. Hey, Sonia, it'll actually send the event to the integration, which is a Lambda function. It can be a step function. It can be a container. It can be an EC2, all kinds of things. But to answer your question, it is the front door to any application, and then it can route based on headers, paths, all kinds of things. All right, so we have the question. Hopefully that answered that. I will give another one. I just did. Let me find this while we're talking. I just did a talk on. I didn't know API Gateway did that, and this is a cool one to see. Sorry, API gateway. Sonia, I'm gonna give you another link if I can, real quick here. We'll share it, copy it. We're just doing this on the fly, aren't we? All right, so here's another link. If you want to know more about API Gateway, this session, I just did the session at reInvent this year. It actually talks through, it's called I Didn't Know API Gateway Did That. And it literally says, did you know API Gateway does this and this and this? And it gives some examples of how that works. So, all right. So let's go to the question, what role do serverless functions play in microservices? This is a fantastic question. They have a compute, right? So eventually you need compute. You need to run business logic, right? Now we do a lot of things here that you can do a lot of configuration before you ever use a Lambda function. Do a lot of things at API Gateway, but eventually you need to run your business logic. And so if you think about a website, okay, and we're going to talk real simple for a minute, okay? You think about a website, maybe it has, okay, when I'm looking, I go www.mywebsite.com/users, and I want to get a list of users. Well, I could have one Lambda function that does everything. Okay, I have /users to get users. I have /reports to get reports. I have /orders to get orders, and I can point them all at one Lambda function. Okay, but then what I'm building is basically a monolithic app. I have one Lambda function that has thousands of lines of code. It says if this is users, do this. If this is reports, do this. If this is orders, do this. However, instead, I can say I have one Lambda function that just handles orders. I have another Lambda function that just handles reports, and a third one that I'm so sorry. A third one that just handles let's see. I have orders. I think I have orders, reports, users. There it is. Now, I'm sorry, folks. Give me a moment. I'm sorry. I tell you what, something's going on in my throat. I apologize. Now, so I've got those three Lambda functions. Then when I make a call on API Gateway, I can say, if it's orders, go to this Lambda function. If it's reports, go to this Lambda function. If it's users, go to this Lambda function. What I've now got are microservices that are part of a bigger application. So what do they have to do in microservices? They're the compute, and you can set those up. And we've seen people get super granular. Like I have for every get on users, that's one Lambda. For every post on another users, that's another Lambda. That's probably a little too much. But you break those down in logical application domains, and those become microservices. So hopefully, Rahal, that answers your question. And do we have any other questions coming in? All right. There's someone else join. Uh-oh. Okay. Well, Sonia, if we don't have any other questions, I can talk, or I can whatever you want me to do.
I think we're done with the questions.
All right. Good. John V says, I'm thoroughly enjoying the way. Thank you very much. I'm loud. There it is. Thank you. All right, good. We have some good feedback coming in. I encourage you, if you want to learn more, like I said, EDJ Geek on Twitter, hit me up. Serverless Lands, I'm going to point you to Serverless Land almost every time. But I appreciate you giving me your time and letting me talk to you. And I'm super excited. I was telling Sonia before we got on this, I love students. I absolutely love, and someday I'm going to come there and I'm going to meet you all. So I'm super excited to do that. So
looking forward, sir.
Thank you very much. I appreciate that.
With immense pleasure and gratitude, I thank you, sir, for enlightening and inspiring us with your wealth of knowledge and experience. Your presence here today has added immense value to our event, and we are honored to have had the opportunity to learn from you. Once again, thank you, sir, for sharing your expertise with us. We look forward to the possibility of welcoming you again in the future.
Absolutely. Thank you very much. We'll see y'all later.
Thank you, sir.
Bye bye. Thanks all.
I'm now going to display a QR code which you can scan to obtain your certificates. I hope everyone has scanned the QR code. I also thank all our attendees for contributing to the success of today's webinar. This brings us to the end of today's session. Thank you and have a wonderful evening ahead.